Here's an example I wanted to review with you guys that might help you with the test. And so I'm just going to read the question. Consider a function g of x continuous on the closed interval -3 to 2. And g of -3 is equal to 5 and g of 2 is equal to -2. If g of x is equal to 1 for only one value of x, then x equals, and we have the multiple choice selections. So a few things that we want to point out. One of them is that g of x is continuous. And so just by saying that g of x is continuous, it makes me think of the theorems that we went over in class, the extreme value theorem and the intermediate value theorem. Because that's how the theorems begin. They say if a function is continuous on a closed interval. The other thing that I'm interested in is these statements here. G of -3 is equal to 5 and g of 2 is equal to -2. And many students might be a little confused by those symbols, but they're just notation for points. So for instance, the very first one here, that's saying you have the point -3, 5. Because x is -3 and g of -3, or the y at -3, is 5. So that's just a coordinate point. And same thing for this section here. G of 2 equals -2. That's just saying when x is 2, the g value or the y value is -2. So if I want to write that as a point, that would be the point 2, -2. So let's read the question one more time. Consider a function g of x continuous on -3, 2. And there's the point -3, 5 and the point 2, -2. Now the next part, g of x is equal to 1. And what is that saying? That's saying you also have another point. I don't know what the x is, but the y is 1. Can you see it from here? We don't know what x is, that's why they left it as x. But the y value, g of x, is 1. And this happens for only one value of x. So then they want you to tell them what must the x value be, which is this x value. So if we gave you 2 points and we told you that the function was continuous and I'm giving you a y value now, then what can you tell us about the x? The first thing I'll notice is that this y value, 1, happens to be a number between 5 and -2, isn't it? 1 is a number between -2 and 5. And so the best thing to do with any of these examples is if you see points and there's not that many points, then what you should do is plot the points. And so that's what I'm going to do. I'm going to plot the point -3, 5. And I don't have to be too precise. I'm just going to say this is the point -3, 5 and the point 2, -2. And again, it doesn't matter what scale I'm using because no one's going to pay attention to my picture. It's just a visual aid for me. So the point 3, -3, 5 and 2, -2 down there. And now they're saying that the y needs to be 1. So where could that happen? Well, let's see. If the function is continuous, that means that somehow I need to get from this point down to this point without having gaps or breaks, interruptions, or steps or asymptotes. It has to be a continuous motion from one point to the other. Exactly how the path goes, I don't know. But I know that it has to be in a continuous fashion. Now let's look at the answer choices and see if they make sense. The first answer choice is -3. So let's pretend we have -3. Would that be okay? Would that point work for my function? Well, if I have to point -3, 1, wouldn't that be over here somewhere? And -3 is not going to work because I already have a point at -3, and it's 5. And my graph cannot go straight down and then this way, because if the graph goes straight down, then this is no longer a function, and the problem said consider a function. So -3 cannot be the right answer, and that means answer A is wrong. Well, now what about answer choice B, -6? So hold on. So this is not going to work. What about the y has to be 1, because they said that g of x is equal to 1. And my next answer choice says -6. Well, -6 is out here. And could it be that -6, 1 works? If you remember the theorem, the mean value theorem, it says that if you want to get from this point to that point, you have to cross all the y values between them, but it says that you have to make it between these two numbers, between -3 and 2. So if I go outside of the original domain, -3, 2, look back at the question. It says that g is continuous only on -3, 2. So I have no idea if the graph is continuous outside of -3, 2. And that tells me right away then that -6 is not a good solution, because -6 is not even in the domain of -3, 2. So I cannot guarantee anything outside -3, 2. And that's what makes part B incorrect. What about C? C says the point 2, 1. Would 2, 1 work? Well, here's 2, 1. 2, 1 would be here. And do you agree that it's the same reasoning as having the point -3, 1? If you have 2, 1, then this is no longer a function, and then this is no longer true, but I need it to be true, so it cannot be C. And part D, so this is wrong. Part D would be 3, 1. And what about having the point 3, 1? Well, 3 is outside the domain. Remember we talked about this domain, -3, 2. And so anything outside -3, 2, I can't guarantee any results if I use any of those numbers. So 3 is outside the domain of -3 to 2. And the intermediate value theorem does not guarantee anything outside this domain. And so 3, 1 is also the wrong answer. It must be -2 now, but let's take a look at it. Where would that point be? The point -2, 1. The point -2, 1 would be somewhere here. And then, would that make a continuous function? If I have to go from this point, and I have to land on this point, and somewhere in between I need to be continuous, could it be that it goes from here to there and then down here? Yes, that could happen. And moreover, this point -2 is inside the domain -3, 2. So it makes perfect sense. I can have a graph that goes like this, and it is continuous, and it touches touches the point where y equals 1. And so that's how I know E is the right answer. So just to summarize, anytime you see notation like this, these are just points. That's an x, that's a y. It's one point, a coordinate, and you can plot it. This is also a point, plot it. And here it's half a point. They're giving you the y, you don't know the x. So just think about it when you put it all together. Okay? when you are given points, recognize them as points and plot them. I now want to talk about functions that look like this. Y equals, say, absolute value of x plus 5 over x plus 5. And I could ask you things about the continuity of this function. So anytime you see a function like this with an absolute value, and it has to be a fraction, and either the numerator or the denominator, they have an absolute value, and the other part of the fraction has exactly the same thing but without the absolute value, then you should recognize all these as step functions. Step functions. And we talked about them in class, and it's very easy to plot them. This is what they look like. First, figure out when is this undefined. It's undefined whenever the denominator is equal to 0. So take the bottom and set it equal to 0. The bottom is x plus 5, and so that would be x equals negative 5. So now you can come to the graph and say, okay, I'm expecting something to happen at negative 5. That's where the break happens. And now all you have to do is test values. And so test values to the left and to the right of negative 5. Try a number to the right of negative 5. Say x equals, I don't know, any number to the right of negative 5. I'm going to go with 1. If you try 1 and you plug it in here, what would you get? 1 plus 5, 6, absolute value of 6, 6. 1 plus 5, 6, positive 6 divided by positive 6, I will get a 1. So when x is 1, y is 1. And so what that means is, here's 1. You tested a number to the right of negative 5, and you got 1. That means any value you have to the right of negative 5, you'll get a positive 1. And so I can graph it like this. That should be touching the 1. And what about if I test a number to the left of negative 5? What might that be? Like, I don't know. Let x equal negative 7. That's to the left of negative 5. And just do some quick mental math and plug it in here. Negative 7 plus 5, that's negative 2, but the absolute value would be positive 2. And then down here, negative 7 plus 5, that is also negative 2, but there is no absolute value, so you're stuck with a negative 2. So that's positive 2, negative 2, the division becomes negative 1. So y equals negative 1. And because you tested a number to the left of negative 5, then anything to the left of negative 5 is also going to be negative 1. So there's negative 1, and there you go to the left of negative 5. You should expect that. So that's why it's called a step function. And what happens right at negative 5? Do you get any values? If you plug in exactly negative 5, you get 0 divided by 0. That is not defined. So right at negative 5, you should have an open circle and an open circle. And now we could ask all sorts of questions. For instance, is f continuous at x equals negative 5? And the answer would be no, it's not continuous at negative 5. Because if I take the limit from the left, I'll get a certain number. If I take the limit from the right, I'll get a certain number, a different number, and so it's not continuous. Just know how to graph these.